In this video, you're going to see the 25 elements that you're going to need to know. With each of the elements, you're going to have a symbol, how many electrons it has, and then some common facts. I'm going to have you create index cards. Please write the element name on the front and the symbol on the back with some chosen facts. Now, you don't have to write all the facts, but if you can choose some of the main facts that you're going to need to know, I'm going to try and give you as many as possible to differentiate one element from another, as there is some overlap of some of the characteristics. The first element we're going to look at is hydrogen. Hydrogen has one electron. The sun and stars are primarily consisting of hydrogen and helium. It's an explosive gas. The Hindenburg is a famous dirigible that caught on fire a spark, ignited the highly flammable gas of hydrogen, killing many people on board. It's used for welding, making of plastics, and rocket fuel. It's also found in water, methane, sugar, many organic molecules, and it's one of the four main elements important for life. Helium has two electrons. Its level or energy field is full, so it is called an inert noble gas. Inert refers to it cannot bond with something else. So helium will never be in a compound. It is inert. It is the lightest gas. It's also odorless and colorless. It's lightest, as you're probably aware of, with the use of helium for birthday party balloons. Can also be used for making things very cold, in the use of cryogenics, which is, you're probably familiar with sci-fi, freezing people for time travel, but in reality, it's more of seeing can materials survive or be impacted by very low temperatures. And it's also combined with neon gas to create lasers. Now we have lithium. Lithium has 3 electrons, 2 in the first level, which don't impact the bonding, but then we have the valence level, or the outer level, and that's what's actually going to be used for bonding. Now there's something called the octet rule. An element, an atom, needs to have 8 electrons on the outside. So lithium only has 1, so it's going to be drawn to other elements or other atoms to form a compound. So if an atom has 7 electrons, lithium is going to be brought over to that to fulfill the 8 electrons. So lithium only has 1 valence electron, which is valence referring to the outer shell. The metal is a silvery soft metal. Now you're going to see throughout all of these elements, many of them are going to be silvery soft metals. It's going to be the lightest metal, and it's primarily used in batteries, specifically the lithium ion battery used in many cell phones or rechargeable batteries. It can be also used in medicines to help treat mood disorders such as a bipolar disorder, and can be used as a coolant in air conditioning and refrigeration. Now, carbon is the second main element that you need to know dealing with organic life. It's one of the 4 main elements for living things, and carbon has a total of 6 electrons, 4 on the outside. So carbon is generally going to want to bond with maybe 4 hydrogens to make methane. Carbon is primarily found in coal and other fossil fuels, which refers to dead, living organic materials. It's also found in sugar, carbon dioxide, and also in diamonds and graphite, which we use in pencils. Now we have nitrogen. Nitrogen is our 3rd main element for organic life. It's primarily found in the atmosphere, in the air we breathe. It's found in amino acids to make proteins, and it's also found in ammonia, fertilizers, and explosives. Think of nitroglycerin. Then we have oxygen. Oxygen is our top. Out of the four elements used for or important for human life, oxygen is the main one. You can see 65% is going to be of the human body made of oxygen. Oxygen is going to make up 21% of the air, and it's also found in water, many minerals, and the Earth's crust. So many organic materials such as sugar. Now we have fluorine, which is the element. You might have heard the word fluoride, which is the ion. And then we have the word fluorite, which is the mineral. Now fluorine is going to be a yellowish poisonous gas, and it is going to be the most reactive. It does contain 9 electrons, so 2 in the first level, 7 in the outer level. So that means it wants to have one more electron to be complete, so it will make a bond. It is going to contain trace amounts of fluoride. The mineral fluorite is bioluminescent, meaning it can glow in the dark, in caves. A lot of raw fruits and vegetables contain fluoride, such as apples and bananas and avocados, as well as meats such as chicken and sardines. It's found in toothpaste and dental treatments. Now we have neon, which has 10 electrons, 8 on the outer shell. So just like helium, it is inert. It does not, and it cannot bond with anything else, so it cannot be found as a compound. It is an odorless, colorless gas and can be used in neon signs or advertising signs, giving a reddish-orange color. It can also be used as a coolant in cryogenic refrigerants and lasers. We talked about the neon helium laser. Now we have sodium. Sodium is a silvery reactive metal. It will react violently with water. Sodium, however, which is very poisonous and bad, sodium can bond with chlorine, and when it creates a compound, it has totally different characteristics. And that sodium and chlorine bond creates salt. And so we can put salt in water without it blowing up. It has new characteristics. So we have sodium, which is the element symbol Na. And Na comes from the Latin word. And we're going to see quite a few elements have different symbols. Why didn't we just say S for sodium? Well, it's because it comes from the word in Latin. Now, sodium helps with the skin and teeth, with muscle and nerve ions to allow for muscles and nerves to move and work properly. It's also found in baking soda, soap, and glass. Now we have magnesium. Now, magnesium, as you see, another silvery metal. It's a lightweight metal. It primarily will give chlorophyll, this green color in plants. It does react as the metal itself. It does react violently with heat, and it will react by flashing. Think about the sparklers, camera flash bulbs, fireworks. So this will react violently with heat and fire. Now we have aluminum, which is a very thin, malleable metal. Malleable meaning it can be hit down and pounded down into something that is that can take a shape. It can be made into flat sheets. So it's a very lightweight, non-corroding metal, so it doesn't rust. It can be found in granite and certain gems. It can be used to make soda cans, aluminum foil, and different kitchenware. Now we have silicon. Silicon is also found in sand, which is silicon dioxide, can be used to make glass as well. And also, if you ever heard of Silicon Valley in California, this is basically referring to computer chips, the silicon in computer chips, and also silicon gels. So the element symbol is Si. Please don't confuse this with S, which is sulfur. Now here we have sulfur, which is S. Sulfur gives off a rotten egg smell. It is found in eggs, beans, nuts, cheese, cabbage, garlic, and many types of fish. Can also be found in skunk spray. The skunk spray can give off that smell. Natural hot springs or volcanoes will give off this sulfur smell as well. Now we have chlorine. Chlorine is Cl, not Ch. Now chlorine will give off a greenish yellowish gas. Even when it's in a liquid form, it will give off that color, but it is a poisonous gas. But just like with sodium, even though it is very harmful, God did design it as it bonds with something else, as chlorine bonds with sodium. Two very harmful, deadly elements bonded together will form something good for our body, and that is salt. Chlorine is also found in stomach acid, can be used in bleach and other disinfectants to kill bacteria and viruses, and also added to the swimming pool to do the same, killing bacteria. Here we have potassium, which is also a silvery metal, and potassium can be found in the igniting part of matches. Phosphorus can also be found in the match as well, but potassium can also be found in trace amounts of bananas. Now, potassium, just like sodium, can react violently with water, but when you throw a banana in water, it doesn't explode, okay? So when we say trace amounts, we're talking about microscopic amounts of this element is found in the fruit. So our body is able, as it digests the fruit or the vegetable, can use this element. Remember, it's on a microscopic molecule level. Potassium is also important for blood clotting. Sometimes when babies are born, they might be injected with a potassium shot to prevent blood clotting. Also, when they cut the umbilical cord, potassium can be found in gunpowder, soap, and fertilizers. And something important here, just like iron and just like gold and silver and copper, why don't we have the letter P? We have the letter K, and that comes from the Latin. Here we have calcium, Ca. Remember, C is just the element symbol. C is for carbon, so we're going to use Ca. And calcium is primarily going to be found in shells and bones. Well, to create healthy bones and teeth, we want to be absorbing calcium. And we can find this in milk. We can find it in vegetables. We can also actually find it in limestone and chalk and antacids. But make sure you're not eating those. Now we have iron. Iron is very important in our bodies. It's the center element of our red blood cells. Inside our body, our blood is a brownish red. When it comes out of our body, it reacts with oxygen, giving it a bright scarlet red color. But our red blood cells, the center element is iron. So that gives our blood this red color. Our blood is not blue. Blood vessels in our skin, but our blood is red. Iron is used in construction. It's a medium hard metal. When it does rust or oxidize, reacting with oxygen and water, it will turn a brownish red orange color. Iron is also found in rocks and soil and the solid core of the earth. Now we have copper, and copper has 29 electrons. The element symbol also comes from the Latin, cupric. It's an orange malleable metal. Remember, malleable refers to being able to be pounded down or shaped into something, whether it's for wires, to conduct electricity. Just like iron, it will oxidize. It will turn a bluish green color. I remember when I was young, I was given a gold necklace, and it ended up making a bluish green mark on my skin. And basically, that's when I realized it's not actually gold. It was actually copper. And so if you think about the Statue of Liberty, One of the main elements in the Statue of Liberty is copper, and that's why it's actually not meant to be this bluish green color. It's because the copper in the structure, in the metal, oxidize and turn that color. Crabs have copper as the main element in their blood. It gives the crabs a blue color, and copper has been used in pipes, electrical wiring, and a combination of copper and zinc to make brass. So brass is actually not an element, it's actually a compound, and bronze. Bronze is also a compound with copper, and bronze is also a copper compound, and these are used to make pots and instruments. Now we have zinc. Now zinc has been used in cough drops and different vitamins to help with the immune system. It's also great as a coating over metal to prevent rust. It can be found in trace amounts of beef, oysters, oatmeal, tofu, and chicken. It can also be used as a fertilizer and found in batteries. Now, the word galvanize refers to a protective coating. So if you ever heard of a galvanized metal or galvanized steel, that means this zinc coating or this protective coating is placed over the metal to prevent it from rust. And as we just said with copper, copper combined with zinc can make brass. And this is a new compound. Then we have arsenic. Arsenic is a poisonous metal. It's a very brittle metalloid. What metalloid refers to, it has characteristics that kind of are in the middle or in between what a metal would be and a non-metal would be. So basically we would have something that would be more brittle. Maybe a non-metal is kind of like sulfur. It's more brittle. We're not necessarily talking about a gas, but a cross between a metal or non-metal solid. Arsenic has been used for rat poison, car batteries, and ammunition. Now we have silver. Silver in the same way is coming from the Latin, so Ag is not an American or English word. That's why we don't have just the letter Si or Sil. Si would be silicon, S would be sulfur. So we're taking it from the Latin. It's primarily used in silverware when we used to have sterling silver used in jewelry and also currency. It's very expensive. Now we have iodine. Iodine is a violet or a purplish black metal or solid. It is used as an antiseptic. Placed on wounds in a liquid form, and it actually turns the skin an orange color. It's used to kill bacteria during surgeries. It's important to help balance your thyroid. If someone has a thyroid issue, which is in the neck, the thyroid will swell up, and so it's important to have the right amount of iodine. It's found in, or can be added to salt, iodized salt, and can be added to drinking water. It's found in seaweed, oysters, strawberries, cranberries, and eggs. Then we have gold. Gold, just like silver, that Au is coming from the Latin. It's a soft yellow metal. Gold, just like silver, the Au comes from the Latin. It's a valuable metal, but this metal is a soft yellow malleable metal, very important for currency and jewelry, and also can be used in little electric contacts in electronics. Then we have mercury, which is a liquid at room temperature. It's a liquid metal. In the past, it was used in thermometers, thermostats, barometers, but now we try and move away from that because we know it can be easily absorbed into the skin. It's very, very toxic, and it has also been used in fluorescent light bulbs. Now we're going to end with lead. Just like mercury, it is very toxic. It's a silvery metal. It's non-corrosive. It has been used in cups and plates and dishes, piping. But because we know it's very poisonous, we have moved away from that. It was also used in pencils. That's why we called it pencil lead. Nowadays, we don't have lead in pencils. When someone says, "Can you give me some lead, pencil lead?" That's just based on what it used to be called. Now we use graphite, which is pure carbon. So we should be saying, "Can you please give me some graphite for my pencil?" Lead has also been used Lead has also been used as a radiation shield. If you ever had to get an X-ray, they may put something over you that may contain lead.